In question 19, I counted this as all extra credit, just to see if you could problem solve with your skills that we've been working on. The profit from the ticket sales at a local comedy club can be modeled by the function P at X equals, then you got your equation where X represents the price of a ticket. Find the ticket price that will generate the maximum profit for the comedy club based on the ticket sales and the ticket price here. So find the ticket price. That's going to generate the maximum profit. Now, as soon as I start keying in on the word maximum, maximum tells me that I should be looking for a vertex. Now, it's a quadratic equation, and quadratic equations have two shapes. They're U-shaped. And because the quadratic term, this 10x squared, is negative, I know it has to be a frown. So you did not have to graph this to find solutions, but I think it helps in the explanation of what I want to do. What I have is y-intercept of 1250, so I'm just going to call this point 1250. That is my y-intercept. I also know that it's going to frown, and it's going to have a maximum point. Well, a maximum point has to be higher than a 1250, so I'm just going to call it my maximum point. So I've got a curve that frowns and does something like this. The point I want to make is that if we're going to find the maximum, we're going to need to figure out what is the ticket price that generates this maximum output in money, or generation in profit, P at X. So in order to find that, I'm really just finding this axis of symmetry that we've done earlier on the test or the quiz. So I want to find the axis of symmetry, and that value, the X, the ticket price that will generate the maximum, can be found by taking the negative B all over 2A. So what is the ticket price that would generate the maximum? We'll take the opposite of B, which is 200, all over 2 times A, which is a negative 10. And you get a calculation of a negative 200 divided by a negative 20, and that's going to give you a positive $10. So when our ticket price is $10, we end up with the maximum profit. That's what the follow-up question is. What is the maximum profit? Well, if I know what my ticket price is, if I know my ticket price is at $10, then I can find out what that profit is if I plug it in to the function. So that means find the profit at $10, which is 1,250 plus 200 times 10 minus 10 times 10 squared. Well, that's 1,250 plus 2,000, then minus, well, 10 squared is 100, and 100 times 10 is 1,000. So if I take 1,000 from 2,000, I'm left with 1,000, and I got to add it to the 1,250, so that gives me $2,250 is the maximum profit that I'm going to make at this comedy club. And if I make each guest that comes in pay $10, that'll maximize my profit. The third bullet or question said, at what ticket prices will their profit be equal to 0? Well, that's another reason why I did the graph. I wanted to illustrate where your profits are 0. Your profits are 0 when your graph or your curve hits the x-axis. So this is where our profit goes down to 0. So what are those prices that will give us a profit of 0? So in essence, what we want to do is we want to drive our profit to be nothing. So 0 equals 1,250 plus 200x minus 10x squared. Okay, and then we're going to solve this. Now this is where you had to figure out how you wanted to solve it. By factoring was our only method that we worked with, so I'm hopeful it's going to factor. So they all have a common factor of 10, so I'm going to divide everything by 10, and so that I have a nice number to work with out front, I'm going to divide by negative 10. So I'm going to divide everything by negative 10, even at 0. But 0 divided by negative 10 is still 0. 1250 divided by negative 10 is going to be a negative 125. I'm going to rewrite it so it's in the format I'm used to. And a positive divided by negative is negative, and that's going to give me a 20x. And then a negative divided by negative is positive, it'll give me a positive x squared. So that was a negative 20x and a positive x squared. So what I've done is I've divided them by negative 10, created a positive x squared, a negative 20x, and a negative 125. Now I've got some manageable numbers. It's a trinomial, and if trinomials are factorable, they have to be factored into binomials. The signs have to be different, so I know one's a plus, one's a minus. So now I need factors 125 that when I add them together give me, or in this case when I subtract them, since it's a negative 125, subtract them give me a 20. So I'm going to use 25 times 5, because if I have 5 quarters, it's $1.25. So here's the factors that I can multiply together to get 125. And if I have a negative 25 and a positive 5, I get the negative 125, and I also add up to give me a negative 20. So we're going to use a negative 25 and a positive 5 for our factors. Then we're going to apply our zero factor theorem, which says I know then that my ticket prices had to be either a negative $5 or my ticket prices had to be, I'm sorry, I know what I wanted to say, but I wrote it too fast. X plus 5 has to equal 0, or X minus 25 has to equal 0. So my ticket price either is a negative $5, which is really not very reasonable. We're not going to give money to people to come see our show, so that's not going to work. But we could say if we charge too much, if we charge $25, then there's nobody interested in coming. The ticket prices are too high and the profit is 0. So a $25 ticket price is going to drive people away to the point where they won't come anymore. So our $25 mark here is where our ticket prices are too steep. So anywhere in between 10 and 25, 10 gives us our maximum, and all the way over here, if we gave them away, this says if we give our tickets away and we don't charge them anything, 1,250 people will come. So anywhere in between 0 and 25, we'll have 1,250, all the way up to a profit of 0, all the way up to a profit of 2,250, but we could drive down our profits down to 0 if we charge too much. So that's what was expected for you to get your extra credit.